Okay, this video is about the margin of error and the confidence interval and how to calculate them. Well, suppose the true average weight of 100 products is 25.18 kilograms and you take a sample of 10, and this is the average of the first sample. The second sample of 10 shows this average. This is the average of the third sample, the fourth sample and the fifth sample. So you can see that every time you take a sample, the average of the sample isn't the same as the average of the population. And that's always the case when you take a sample. So that's why we work with margin of error and confidence intervals. So this is the average of the first sample. And when you calculate the margin of error, it's 0.13. How did we calculate it and what is it? Well, the margin of error indicates how close or how far the result of a sample can be from the population parameter. So, how do you calculate the margin of error? Using a formula. The margin of error for averages should be calculated different than the margin of error of percentages. And in this video, we will show you how to calculate the margin of error for averages or mean. The margin of error for the mean is the standard error times the z-value. The standard error, what's that? Well, that's the standard deviation of the sample means. So you saw that 5 samples had 5 different averages or means. So you can calculate the standard deviation of the average of the samples. Well, of course, you don't want to take multiple samples because it takes a lot of time. So you can calculate the standard error with a formula. And how do you do that? Well, it's the standard deviation of one sample divided by the square roots of your sample size. So the sample size was 30 products. So the standard error is the standard deviation, and that was 0.365. You divide it by the square roots of the sample size of 30, and then you see that the standard error in this case is 0.0666. Well, you use that to calculate the margin of error, and that's the standard error times the z-value. How do you know the z-value? Well, you can look it up in the z-table. The table for the standardized normal distribution. So when you want to have a confidence level of 95%, you can look up what the z-value is, and that's 1.96 rounded till 2. So now you know the standard error, you know the z-value, so you can calculate the margin of error, and that's the 0.0666 times 1.96, or rounded 2. So the margin of error is 0.13 in this example. And you're pretty confident that you will catch the true average of the population within the margin of error to the left and to the right. And that's the confidence interval. So with a certainty level of 95%, the confidence interval is shown, and you probably will catch the true average within that interval. Well, suppose you want a confidence level of 90% instead of 95%. What will happen to the margin of error? Well, it will become 0.11 instead of 0.13, so it will be smaller, the margin of error. And you can see that using the formula. When you want a certainty level of 90%, the z-value you will be using will be lower than 2, namely 1.64. And using that z-value will lead to a margin of error of 0.11. Because you multiply the standard error, and that remains the same, 0.0666, times the lower z-value is a smaller margin of error, and you can see it here. With a 90% confidence interval, this will be your margin of error. So you will miss the true exact average of the population. You will miss it 10 out of 100 times instead of 5 out of 100 times. What will happen when you want a confidence interval of 99%? Well, it will lead to an increase of the z-value you will have to use. So the margin of error will be larger. And you can see that over here with a 99% confidence interval. The margin of error is 0.17 when you calculate it instead of 0.13 or 0.11. And the interval is wider. So you're more sure you will catch the true average of the population within this interval. You will catch it 99 out of 100 times. Well, if you want to reduce the confidence interval, option 1 to do that is to increase the sample size. What will happen if you increase the sample size? Well, the average of the sample will be closer to the true average. Hey, and when you research the entire population, you will hit the exact true average. So that is what's happening when you enlarge the sample size. And when you enlarge the sample size, the interval will be smaller as well, because you will divide the standard deviation. You will divide it by the square root of the sample size. And when the sample size is 30, this will be the standard error, 0.0666. When you divide it by the square root of a sample size that is 60, the standard error will be 0.047. So you can see that the margin of error will be smaller with a larger sample size, and the interval will be smaller. All right. Option 2 to decrease the confidence interval is to decrease the confidence level. And you already saw that because you saw what happens when you want a confidence level of 99%. You saw that the interval will be wider. Okay, so now you know what the margin of error is, what the confidence interval is, and how to calculate them.